Hi, welcome to Raw Math. Today I'm doing a series of videos on exponential equations. If you saw my last video, I introduced how exponential growth works when the numbers grow. This will go the other way. The question is, what's the difference between growth and decay? And the difference is, when you're growing a number, you add each time to your base. When you're going down, you have to subtract. So a new settlement is built around a park. As people move into new houses with their dogs, the rabbit population in the park decreases by about 8.3% per year. Before the start of the new settlement, there were roughly 38 rabbits. How many will be left after 10 years? All right, what was the original number of rabbits? Well, that's about 38 rabbits. You'll notice I almost always label my numbers so that the numbers have more meaning. It says, what is the rate of decay written as a decimal? So percent literally means per 100. Cent is our prefix for 100, which is why there's 100 pennies in a dollar, and we call 100 years a century. And centurions, if you're wondering, were groups of 100 soldiers. So cent means 100. So 8.5 per 100 is 0.085. Okay. If 100% of the number of rabbits is written as the decimal 1, what is the decimal equivalent of the decay, the decreased value from the original? So we want to take 100% of the rabbits and we want to subtract 0.085. Now, you can leave it as 1 minus 0.085, or you can write it as 0.915. Here's the deal. This is easier to write. This is easier to translate. If I see this, I automatically know it's a decay problem, decay meaning subtract, of 8.5%. If I see this, I'm going to have to calculate that decay. Now, I have videos in this playlist, and I have videos on my YouTube channel that talk about how to calculate 8.5% from 0.915. And please go to those videos after this if you want a little bit more information on that. Okay, so then it says, write an equation for the decayed number of rabbits. So here it is. When we write an equation, we start with the original number, which is 38. We multiply that, our decayed factor. This is a factor in which we either grow or decay. This is decay because it's less than 1. If you multiply by 1, it doesn't change. If you multiply by less than 1, it's decay. If you multiply by more than 1, it's growth. And you never multiply by a negative because that would make things wackadoodle. It would bounce all over the place. So I'm going to stick with the 1 minus 0.085. You are welcome to go to the other form. I just really like the clarity of this form. And then my exponent is going to be t. It's exponential. We multiply by this decay factor. So every time we want to go down, we need to multiply. So it's an exponential because the exponent is a variable. It says, what is the amount of time in this situation? Well, it says up in the original problem, it says 10 years. So down here, I'm going to say 10 years. Again, labeling my number. I don't necessarily label factor because a factor isn't a number that gets labeled. It's just kind of your ratio, just like your percent. Once you get rid of the percent sign, this is not a labeled number. All right, how many rabbits are there in 10 years? So 38 times 1 minus 0.085 to the 10. Again, this is probably going to be your easiest way to write it if you want to get clarity, but you are more than welcome to do the 0.915 in the parentheses as well. And I get on my calculator. My calculator says 15.6. I don't know about you, but I've never seen part of an animal. You're either there or you're not. So my answer is going to be 16 rabbits. Remember, this is all guesstimated numbers. This is a story problem. Nothing is precise. We're trying to predict. So we are allowed to round this up to 16 rabbits. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you in the next video. Thanks.